Well, hi everyone. Math is going to be a little different. School is going to be a little different here for a few weeks, and we're just going to do our best to um, try to continue with your academic growth so that you don't get behind. We're not going to have a ton of time at the end of the year when we go back to do review. So, our packet and your geometry math work you're going to find is a lot of review from the beginning of the year so that you have that time. This is what your packet looks like. You've got some information on the front. This is the video we're talking about that you have posted and ready to go. A couple other things that are in here. The first thing we're going to have you do is review of this unit. So, Unit 7 review. Next in the packet, you have your assessment. It just looks like normal assessment. You've got answers for multiple choice there, or multiple choice. You've got some vocabulary. You've got multiple choice and part 2, 3, and 4. I want to show you, though, at the end of this, there is a reference table so that you can see that. You're going to need your conversions and you're going to need your formulas, okay? Next in your packet is review. So we've done the first 6 units and given you some review, some highlights from each of them. Use your unit books. In this packet, the very first thing is, again, you have a reference table. Okay, so the reference table is there within this packet. We've also labeled them. They're in order, but we've also labeled what unit you can get them from. As you notice right away, there's constructions, but these are multiple choice. There are going to be some places that maybe you have to do constructions in the packet yourself. This assignment is all multiple choice, but later on there's some mixed reviews. If you have a compass, that's great. If you do not, it's okay. We'll show you later on kind of how you can just show us what you would do and then draw it in, and that will be fine, okay? So as you're working through, you can ask us questions. You can, we all use Google Classroom. You can email your teachers. So this is Miss O'Mara, Miss Perino, Miss Griffin. We're going to be kind of working together to make videos and to help support you. Okay. In this video, what I want to do, the very first thing you should be working on is your review from this unit. So this is the current unit we were working on. That's what we would have been doing this week. We would have finished up with review, and then you would have taken the assessment. So you're going to want to do those first 2 things first and fairly quickly so that that learning that's fresh in your mind can continue to develop and support. Okay. What I'm going to do first is I just want to go through and give you some hints and reminders in this packet. You should be trying to do this on your own. After that, you can then try it out on your own. You can look things up in your book, and then of course you can contact us via Google Classroom or email for additional questions and support. Okay. So here they're talking about the cross sections in number 1, and you're just sketching them out. So it depends on if you have a prism or you have a pyramid on what the shapes are going to be. So first, if we're going to go parallel to the base, we need to know what the bases are. So we've got the bases here of the cone or cylinder. Here's our base of our pyramid. And then these would be our bases of this prism because they are the triangle. Okay, so we want to be parallel to them. So we're going to slice this way, and then this way, so they're parallel to the bases. And as we remember, when we're parallel to the base, they are going to be the same as the base. Now, if it is a cylinder or a prism, doesn't matter where you slice it, they are going to be congruent. And if it is a pyramid or a cone, of course, they are going to be similar to the base. Okay. Now, if we want to go perpendicular, so now we're going to go 90 degrees to those bases when we cut them. Okay. Now it's going to depend on if it is a prism or a pyramid. So if it's a prism, then it's going to be that shape that you see there. If we connect it, those 4, what shapes do we have? They're going to be a rectangle. And then the pyramid, you can see the shape right here. If I were to cut perpendicular, you're going to get the shape of a triangle. Okay. This one down here, a 3, 4, 5 right triangle is revolved. Remember these rotations that we're doing around one of the legs of the length 4. So this is specifically, they're giving you lengths of the sides of the right triangle, and it's telling you what to revolve around to create a solid. Describe the solid, including the dimensions. That's why they gave you 3, 4, 5, and find the exact volume of this solid. So I'm just going to draw it out. It's a right triangle. 3, 4, 5. So 5 has to be the hypotenuse. So this one looks a little smaller, and then that would be our 4. We're specifically revolving around the 4, so that's where I'm going to draw my pole. And so think about this being like a flag. It rotates around. What's the solid? What would the measurements be? Height, a base, a radius, whatever it might be, and then you can find your volume from there, okay? Over here, every time we see these, right, what is the volume of the sphere? You're going to write your formula down. So go to your formula sheet. You also need to pay attention to what it's asking you to round to, or if you need exact, okay? Ratios. Let's go through the ratios. So we have the ratio of the side lengths of 2 rectangular prisms. It's giving that to you. And once you get to the volume, the ratio of the volume prism, and define the volume of the larger prism, and they give you the smaller prism. So the problem is we have similar, but we have a ratio that is one-dimensional because that's the sides, and we need to find a three-dimensional because it's volume. So we're going to have to convert. So I'm not going to do the problem, but we're going to go through these ratios again. So remember, ratio of the sides, which is that they gave you. This could also be the scale factor. And it doesn't matter what sides. It could be base, height, length, radius, diameter. They're all going to be the same. So we can do ratio of the perimeters, which is one-dimensional. We have ratio of the areas, so that's two-dimensional, and ratio of the volumes, which is three-dimensional, okay? So we have each of those. Perimeters is one-dimensional, and what is a side? Well, a side is one length, so it's also one-dimensional. So if this is A to B, the ratios of the perimeters are going to be the same. Technically, it's A to B to the first power. Anything to the first power, because it's one-dimensional, will be the same. Now, areas, however, they are not equivalent. We have to square it. So we would have A squared over B squared. And then volumes, of course, are three-dimensional, so we take our one-dimensional and we cube it. Now, if you want to work, if you're at two-dimensional and you need to get to three-dimensional, we have to go backwards. So the inverse of squaring something is the square root. So we would take the square root to get back to one-dimensional, and then we can cube it to get to three-dimensional, and so on and so forth. Volume, again, of a prism, so you're going to use your formula sheet. Down here, methods of proving triangles similar. So these are our angle, side angle stuff. A combination of A's and S's. There's 3 methods for similar. I'm going to tell you that. I'm not going to tell them to you yet because I want you to think about these, and that's basically the answer. The next page is congruent. So be careful when you're looking through it. Congruent has how many methods? Hopefully you remember that there's 5. Next one, a container for storage is made up of a cylinder and a hemisphere. The height of the container is 40 inches. The radius of the hemisphere is 8 inches. What is the volume of the container to the nearest cubic inch? Do we have a formula for this? No, we do not have a formula for that shape. So we have to think about the shapes that we do have formulas for, which if we look at our reference table, they're right here. So we have the cylinder. So we're going to use our volume formula for a cylinder. And we have a hemisphere, what's a hemisphere? Not a sphere, but a half of a sphere. So we don't have a formula for that, but we do have sphere. So we can find the sphere and divide it by 2. So you need to find, so the method would be, you're going to need the volume of the cylinder plus a sphere divided by 2. And that will be the volume of the container, okay? Cubic box with a side length of S centimeters holds N marbles. The density of the marbles can be determined by the expression what? So how do we find density? You all have that cute little song, how to find it. Density equals mass over volume. So try that out. Draw a picture and see what you come up with. A solid sphere has a volume. So you're going to use the volume formula of the sphere, and you should be able to fill that in. Number 11 looks really crazy. Okay, we're starting with this picture, which is a circle. They're splitting it up into equal sectors, which is just a triangle, but it has a curved end. Okay, that's basically what a sector is. The sectors were then arranged as shown in the diagram below. And now we need to find x. So essentially what we're doing is you have to start with a circle and find your way to this picture. And then what would x technically be? Okay, so we went from the circle. We've got it split down into 24 sectors. They split it in half. So that means there's 12 sectors here and 12 sectors there. So think of this as like a bungee, right? Or a comb. And girls, especially if you have like combs in your, using your hair, you'll kind of get this idea. Then they split it apart, spread them out so they're flat. So what does x represent? Well, it represents the outside, right? Which was the outside of the circle. Which, what do we call that? I'm just going to leave you there. What is that called on the outside of a circle? And how could you use that to help you find that measure there? Parallel lines, we've used those multiple times. Just remember your angles are either congruent or supplementary. So once you fill that in and see. Exterior angle theorem. Find the measure of CAD. That's the outside one. What is the measure of the exterior angle? How do we find that in relationship to angle B and C? Well, remember the exterior angle equals the sum of the opposite interior angles. They're also called the remote angles. Okay. Hexagonal prism. This is kind of like that first one. What shapes would they be? So think about it as a hexagonal prism. If you're parallel to the base, perpendicular to the base, and how many cross sections? We talked about that. Think about how many total sides does the solid have. It has to do with that to find the largest possible cross section. A formal proof. Did not see that this did not print out well yesterday. So BD is parallel to AE. Okay, so add that in there. They're parallel. So you're going to write out a proof depending on, I believe, Miss Griffin, you use statement and reasons. My class, we're just going to write down the givens and then comma the reason. Try it out and see what you end up with. And we will post these before you take your assessment. Okay, this one, if you look at the picture, you've got a cylinder with a cone cut out. And as you read it, it actually wants you to find the outside pieces. And we want the exact answer. So that means, dun, 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 leave the pi. Do not put it in your calculator. You should have pi in your answer. So to find the space outside of anything, and it doesn't matter if it's a 2-dimensional and you're doing area or 3-dimensional and you're doing volume, you're going to take the outside one. So you're going to take the cylinder and you're going to subtract the cone. Okay, so the volume of the cylinder, volume of the cone. Down here, you've got transformation review. So you're going to plot it out. The first one, we want to state and label the coordinates after the series of transformations. So a couple of things. You're going to state and label the coordinates. So you should have them written out, S double prime, W double prime, so on. And we should have a picture. Remember, this one right here is composition. So we work right to left. This is what we're going to do first. So you're going to do the dilation first. And then from that answer, you're going to do the transformation. Isometry. Do you remember what isometry is? Isometry can only be made from rigid motions. Okay, so isometry, rigid motions are translations, reflections, and rotations because the images are congruent. Would be, if they are congruent, then they are isometries. Okay, so you have to decide if it is a rigid motion or not, and then it would be an isometry. Some trig, we have our angles and sides, and it's a right triangle, so you're going to use SOHCAHTOA. Remember that. And then lastly, we have again, Miss Griffin's room will probably use statements and reasons, and mine, we will just write them out. Okay, so try them out. And then, like I said, come back, check your answers, and you'll be on your way to take your assessment. Okay, talk to you soon.